And our final panel looks ahead to the control systems of the future. This session will explore how digitalization, predictive tools, and continuous adaptation can equip control systems to meet tomorrow's challenges. Please welcome our distinguished speakers, Lazar Bizumić, Head of Project Management for Network Control at Hitachi Energy. Product Management. I was wondering which seat are you gonna select. Okay, it is, in a way. We have Ralf Heisig joining us. He's a product line lead for future product development at 50 Hertz. Janko Kosmač, head of the Process Systems Department at ELES, Slovenian Combined Transmission and Distribution System Operator. Matija Naglič, business developer in system operations at TenneT, TSO in the Netherlands. Renata Rubeša, assistant director of the business integration department at the Croatian TSO. And finally, we're in excellent hands with Uroš Salobir, Director of the Strategic Innovation Department at ELES and Chair of the ENTSO-E Research and Development Committee. Uroš is a true visionary in the field of smart grids and innovation, making him an ideal moderator, I would say, to close today's discussions. Looking forward to.
Okay. Yeah, with a bit of luck, we can finish this conference and the summit. Yeah, it's not called a conference; it's really a summit. We have so many excellent presenters, speakers. We had these high-level panels and everything. So we will end up with something very, I would say, down-to-earth topic. You know, we are now touching the control systems. We're touching the real-time control. Just to make a short introduction into the panel. Yeah, even if we are talking about these highly sophisticated, hierarchically important systems, we have to say that they will need to change as well. Yeah? As everything what we heard today, the control systems also need to change. And they're so sensitive, you know, in terms of operations. They're sensitive because they ensure this kind of human interaction. Yeah. So this is the element where humans touch the system, you know, in the most explicit way. So no jokes, you know, around these systems. All the interventions, you know, these systems somehow have to be there when we try to detect the blackouts before they can even intend to happen. Yeah? And usually we prevent the blackouts through the systems. But they also have a specific role because they usually support a lot of new technologies to happen, you know. So if we want to implement some extremely sophisticated new smart or not smart technology, we have to support that also through the control system. So yeah, they're like in the center of everything. And we also talk today a lot about the term which is control room of the future. This is a very connected item to this discussion. So we see that, yeah, maybe, as we heard today, some AI or any future technologies might appear in these control rooms. Maybe I start with the first round of questions by simply asking to connect a little bit the panels from before with this panel. So what do you, as a panelist, see as the key challenges on the energy sector, so outside of our world? Yeah? What are the key challenges that you see somehow on the boundary of our control systems that will require most of the change to happen? So most of the change to happen before or even around 2030. And just to give you an example, so like in the past 10 years, we were talking a lot about reserve exchange, reserve sharing. We have all these platforms like Maripica. So that was like the priority topic to change. So what do you see now as a change? And we start maybe with Matija, we go to Lazar, Renata, and then on. So please, Matija.
Thank you, Uroš. I think Uroš is very kind to me to start with the, I guess, youngest in the panel. I hope I'm not offending anyone. Let me reflect a bit on the day, because I think it was a very interesting day, a bunch of interesting discussions. We are living in a very interesting time, right? Just considering the speed of the change we are undergoing and the innovation we have to do. Maybe it's even the best time of the electricity sector we are living in, right? And I would say it's fantastic to have this, because we are saving the humanity by having all those innovations and developments towards the energy transition. Well, I can only speak of the Netherlands, but 5 years ago, Netherlands had roughly 11% of renewables in the energy share. Today, or last year actually, we had already 55% of renewables in the energy mix, which in total accumulated for more than 50% of the time. So when I'm talking to the operators, they say, in the past we have operated the grid on a kind of daily day-to business, so it was practically every day more or less the same. Today they say they are kind of pioneers, because they have to operate new grid that we are developing on a daily basis. So that's really, for me, fascinating, right? And if you look, and of course, what also surprises me or makes me happy is that the ambition is higher. So in the next 5 years, Netherlands would like to go to 70% of renewables. So we are connecting in the next 5 years roughly 15 gigawatt of offshore wind, which makes the Netherlands the net energy exporter, which is really something new. Does that come with the challenges? Oh yes, big challenges, right? So we're already seeing that we're already actually facing now challenges with respect to dynamic stability, right? Which manifests in a form of interior oscillations, harmonics, resonances, which need to be tackled, managed somehow. But our system which we are using are, I would say, traditional. The technology we are using, I will not say it's outdated, but it's maybe not anymore suited for the challenges, the requirements we have to operate our grid. So we have to innovate a lot. What we should do, and I think I will just more or less repeat what was already said today, is we need better monitoring systems, right? We need not only monitoring, we need to have also better controllability of our grid. So to activate flexibility instantly when this is needed. We need decision support tools. Why decision support tools? Because the complexity is enormous, right? The complexity that the operators have to deal with, which in general are kind of mitigating residual risks that are remained from the operational planning or design phase. The complexity is really huge, so we need to help them there. We need to automate. Maybe AI is the solution. I'm not sure. I often see that AI is presented as the holy grail. For me, it's just a technology that can be used. There is so much more we can do already today without AI. And this is mostly then the call for the suppliers. Help us innovate and move faster. Thank you.
Thank you. Thank you, Matija. Let's go on to Lazar. So what is your take on this question?
Just check it now.
Yeah.
Hopefully, now it's working.
It's strange for the audience, you know. We are struggling because when you have the mic on, there is a red line shining, which is a bit strange, you know, but that's the reality. This is why we're struggling. So, Lazar,
yeah, thanks a lot. Yeah, thanks, Matija. I think you nicely covered quite a lot of topics here. I'll try not to repeat the same things, but now when we're talking about 2030, I mean, in our industry, that means that's right around the corner, right? So I honestly hope that we're not going to face any new challenges that we are not seeing already today, because today already we got more than enough of those. And if we are able basically to keep up with those challenges, to find the solutions, actually, to be honest, I think most of the solutions are already there. Now we have to make sure to implement them in the right way. This is something that all of us, we have to work together, basically vendors and utilities, to properly implement those tools, right? And which is not easy on such a big scale for such important systems. It is a challenge, right? But just to name a few of these challenges, of course, you know that I think that in last probably 5 years, the way we operate the network changed more than in previous 50. And for next 5 years, I think it's going to change even more than that. Some of the reasons, of course, we got, for example, now data centers powering all these AIs. It's incredible how much this is growing. And the problem with that is not just that it's growing, basically, demand for power. It's also the type of a power, the nature of that demand, because it is extremely stiff demand, right? It doesn't help you. Basically, you have a problem in your system. Data center doesn't care. It's going to keep asking for the same power, right? And also it's a very volatile. It can happen that within fraction of a second, load goes from 10% to 100% of a data center, hitting it with hundreds of megawatts, huge things. Then we got EVs, right? Penetration of EVs that's quite accelerating now. This is impacting distribution network first, of course, in many different ways. Just growing electricity demand is one, but it's also basically changing behaviors, changing daily patterns. But on the good side, for example, this one we can use also for flexibility, right? This means that also our distribution grids are changing from passive radial grids. Now we're talking about active network elements. Number of controllable elements is going through the roof, right? And now more and more of course, renewable distributed energy sources where we are replacing relatively small number of big bulk power sources with the thousands, or in some cases even tens of thousands of elements. So all of those quite big challenges. And then to make things even worse, all these new resources, they're hidden behind the converter. It means they don't have inertia in a regular way, right? You can have some synthetic inertia, but basically the consequence is the dynamics of the systems get much faster. So with all these challenges, suddenly everything that before it was taking minutes to happen, now it's happening in less than a second. You don't have time to think. You don't have time to analyze things. You have to act quicker than ever. So we end up with a system that's much bigger than before, thousands of controllable, tens, hundreds of thousands of controllable elements. And instead of having minutes to act, you got milliseconds. So what do you do, right? And to make things even worse, mathematics is quite clear. Problems are not linear, they're exponential, right? Yes,
thank you, Lazar.
We really have to think what to do. First thing is being even able to detect those things, like, for example, frequencies, resonances, oscillations, right? How do you do that? With the SCADA, with refresh cycle of 1, 2, 3, 4 seconds, you don't even see them. Once you realize something's happening, it's too late. So, for example, we need to use more PMUs, phasor measurement units, they have VAM systems, and then there's the next stage also once we learn actually what to do with it, because it's not really very useful if you just see, okay, we have a problem, what do we do with it? Yeah. We need to develop processes around that. We have to develop tools to be able to act on those signals, right? And then we can also base our protection and control on these fast systems. How are we going to basically make those decisions? Definitely we need help of new technologies. It's not secret, all of us, all vendors, we are now investing heavily in new solutions like AI that should help us to quickly make those decisions. Do we have something still working on that? No, many things in proof of concept stage, prototypes, very promising, but it's also a matter of trust, right? We have to see to make 100% sure. Because, you know, if AI makes a wrong decision when it's generating an image picture or something like that, not a big issue, right? But if it disconnects a generator by mistakes, causes a countrywide blackout, it's a quite big issue. So we have to, it's a bit, you know, balancing between speed, innovation, and maintaining a super reliable and secure operation of the system. Yeah, thanks.
Thank you, Lazar. Renata, what would you add to this?
Let me wait for the red lights. Okay, thank you for inviting me. So, as Lazar and Matija said, these are very interesting times, and also the topic of this panel is about the control rooms, and I want to emphasize how the control room is one specific room in a TSO, where the people, the operators that work there are in charge of managing and controlling one of the most complex systems that the mankind has ever invented. So it is a very, very sensitive room. And what do you bring into the room? You have to be very aware of what do you bring to the operator, and how do you bring this new system, new data, new information. Because upon all of this information and data that you bring to them, you have to have some countermeasures or some mitigation measures on what you should do about this new information. Also, as Uroš mentioned at the beginning, in the past decade, the most common word that was used in all of the panels, conferences, was flexibility, and also today was also this topic. But I think that the word that will be in focus for the next 10 years, it will be resilience. Resilience of the power system, and this is in face of all of this extreme weather that is happening and that we are all aware, not only in the energy sector, but we are all even sometimes victims of this terrible floodings, extreme storms, heat waves that happen, and in the energy sector, which have impacts on the critical infrastructure, or extreme heat waves that limit the operational limit of the power lines and so on. So I believe that in the future, the data that we should bring into the control room will be the weather data, meteorological systems, real-time weather data, and forecast. But this weather data should not be only raw data, but integrated into the power system analysis tool, such as the N-1 criterion. As we all should know that the system is run today by the N-1 criterion, and it should be satisfied at all time. But today this N-1 is not enough, as we are aware, or should be aware also, this criterion is not enough, and blackouts happen even if the N-1 was satisfied. So this N-1 and weather data bring us to the risk assessments and the probability of an outage happening, and what will be the impact of this outage, and also what is the probability this outage will happen. And this also brings us into the topic of the congestion management. Also, as we know that the N-1 is connected with the congestion management, and so the congestion management tools are also something that I think that will be brought into the control center, whether in a more simplistic way as a sensitivity analysis, or in a more sophisticated way as optimal power flows, or in an extremely sophisticated way in AI, but I don't think so that it will be so soon. And so this, I think that congestion management will also be a part of the new control system, which also brings us to the TSO and DSO communication and interface, because all of this data should be brought, some of the data should be brought into the TSO. And as we spoke today, there was this information about how the data between the TSO and DSO should be available to both sides, and especially in the TSO, some of this data should be brought, but we should differentiate which data is brought into the control room. Okay. Not all of this data should be brought into the control room, and just some of this data, and we have to investigate which systems are the one that will integrate this data. I don't think that the SCADA system is the one that will be doing this job, but some other data, but there's some other system, but we will see in the future. Yeah.
Thank you, Renata. Yeah. So we have really touched now this human part as well, and I would like to move to Janko. Maybe something more on how far we are going to run the system close to the security limits, and what will be the reaction times. Yeah, please go ahead. Your take on this question.
Thank you. I like what Renata said about the control room, about our end consumers, because what we do basically is we provide services to operators, and operators operate the grid. Now, what I did before this panel, I went to my colleagues from control room and operation and market, and I asked them what they expect next years. And they say, you know, Janko, we expect that there will be a change in market gate closure time to 30 minutes. And this brings a lot of questions to what we do, because schedule will be available for a shorter time, and for that reason the preparation for real-time operation will be much shorter. And then this draws some conclusions from my side, and I will wrap them in 2 points. The first is that we will need fast yet very accurate security assessment tool for the operation for a large observability area, and as already colleagues said, automation tools that will help operator to control injections of active and reactive power from large solar panels plants. So basically what we should do is to equip operators with tools that would enable them to work in more automated way, in more efficient way. Mm-hmm. Another thing that I think is very important and plays major role in what we do for the operator is cybersecurity. Cybersecurity is ramping with the demands, and those demands put a lot of pressure and a lot of extra work to what we do and influence all the systems, all the subsystems, and we need much more time to provide services on a same quality level as today.
Thank you, Janko. Very good take, and we will finish the first round with Ralf. What is the 50 Hertz view on this?
Uroš, thank you. Yeah, you ask for challenges, and one example I always give is, imagine 2013, so already a long time ago, we tried to replace our SCADA system. It was outdated and it was time to replace. And we did it with a standard process, and I can make it short, 2019, we stopped the project, which is the first big project we have stopped at 50 Hertz. So we dare to stop. That was the first thing. Second was we had a problem. Old system and no idea how to continue. And we took a decision to develop our modular control center system. So we said we want to have an ecosystem in a control center which takes care about business process from planning and forecast, real-time grid operation until ex-post analysis possibilities, capabilities. And we have started the development, and we have learned a lot with that. And one thing is, if we repeat things, we repeat results. What does it mean? If we take the requirements from the SCADA systems before and just develop new, we will get the same system again. And then we thought there is more next to the software, next to the technology, next to the environment around. And this is the human. And the human, the operator was mentioned many times, but talking about control centers, there are also data manager and other people, infrastructure guys, which are involved, not sitting in a control center. And by thinking about 2030 and what is the challenge there, I think changing the processes, adapting the processes is what we want. We want to have more power to the grid, more fast response time, not more data. No one wants more data, but more capabilities, more possibilities to act. Yeah, and then said, okay, we need to optimize the processes. The optimization of the processes will lead to the requirements for the new system. And then the operator comes to use it. And if you take a disruptive approach, the operator wants to have always a seat where he or she can control the grid out of the sudden, even at night, every time. And the first thing which stresses the operator is a change. Oh, a new system, a new process. Oh, how should I act then in an emergency case? So, and this is the software addition. So in addition to the software, a challenge we need to handle, because only new system, new technologies will not solve the problems. And what comes going to the operator and involve the operators very early, or all the people involved from infrastructure, data manager, and so on, you get trust. And only if you get trust, you get the acceptance for the new system, and then you can start about manual work as she or he did before, semi-automation to learn how the system is working, or even full automated work. Without trust, that will not work.
Thank you, Ralf. We're moving into the second question, but I will actually take one of the lines from your argumentation. You already mentioned these interoperable systems, and yeah, we know that like 10, 20 years ago, we were opening these control rooms, control systems, support tools, in particular in direction of open protocols, to communicate openly so that we all use the same standards. And then, of course, things move forward. And today we're actually already talking about opening something very touchy, which is called interoperable enterprise service bus. And we're talking about vendor agnostic systems now. We're talking about open source code based applications and software in the control room. So continue with Ralf. So why is this important, and yeah, what should be the optimal strategy for that? I just have to warn that we have to be a bit faster in the second round because we only have 15 minutes left. Yeah?
I will speed up. Thank you. Yeah, you are asking for boundary conditions, and boundary conditions. We could talk for hours here, I think. So I give one example. One example is at ENTSO-E, there was a position paper published in May this year, 25, from the RDIC area, and it covers vendor agnostic solution principles. It's a paper which describes 7 tenets, the basic and key principles for a modern control center system. And these tenets are transparency, modularization, standardization, very important. It was mentioned in a session before. Interoperability, security, cybersecurity, segregation of concerns, only build systems which have a specific purpose and don't mix purposes in one system because you can't replace it. And of course, I mentioned that new way of working, adaptation and changes in the processes. And this paper is published, and when we did a webinar the first time, 175 people joined that. I think 25 TSOs and other companies, vendors, and there was mixed feedback. On one hand, of course, people which did not feel the pain or do not feel the pain we feel and say, yeah, we can continue as before. It's a nice paper, it's a vision. And already a big share of people will say this was needed, and that gives a boundary condition to continue. And boundary condition is not only limiting, also aligning. And then we come to the second, and then I'm really finished. Collaboration and cooperation is one part of the success, that we are not having wild growing systems which are different. Using standards is important, joining the forces, and with that, the time to value will increase, and also the cost can be reduced. And here open source was mentioned. Open source is one of the key elements to share things and do not invent the wheel twice.
So, Ralf, we switched to Renata, which actually might bring us some more on open source. Yeah?
Yes, on open source we did have some also trying with the open source in our system in Croatia, but I would say that the open source is something that I see in non-critical applications that are consumed in the TSO or in the control room. But when we talk about critical applications, we should, let's say, stick to because they are by their nature, these critical systems have to be reliable, have to be secure, and for this reason, I believe that this open source is not something that is already ready to be implemented in the control room, at least not for the mission-critical applications, but for some analysis and so on, definitely yes, because these open source applications that rely on the community and the shared development, these new ideas that bring people and communities is really something valuable, and as Ralf that already says, we don't have to invent the wheel twice. Regarding this vendor agnostic solutions, this is definitely a roadmap that we should all go into that the direction with vendor agnostic solution. And I will just say one more thing, that we all aware that the systems that are integrated into the TSOs and the IT systems develop in a much faster way than the OT systems, and this is also something that is natural, and this is something that is normal, but we have to be aware that what we bring into the control room, these systems have to be reliable and secure, so we have to be sure that we are on that side. Yeah.
That's true. Matija, your take on vendor agnostic systems?
Maybe first on the open source. I think there is a kind of a stigma around open source that it's not secure, which I don't agree with. For me, open source is just one of the means, one of the mediums how you can share software. It's not the solution, but it's one of the solutions, I think. What else? On the vendor agnostic solutions, we need to go this way. We are kind of, I don't want to say forced, but this is the only way to continue. Simply because, as I always say, there is no a single supplier on the market that has the capability to develop what we need. So we need to go for this modular approach. We need to combine the products that are the best on the market to ensure security of supply.
Thank you, Matija. Perfect moment to switch to Lazar now. Our industry representative.
So I need to get red light. Yeah, I feel a bit intimidated. I'm the only vendor here, and everyone talking about vendor agnostic solutions, right? Still,
it's a positive term. Yeah? We even use some more negative terms. Okay. So you should
thank
find
you
us
for being
positive.
so kind, right? Yeah, but I mean, it's clear that interoperability is the name of the game, right? I mean, we've been talking, as an answer to the first question, we've been talking about all the challenges that we are facing. To cope with those challenges, we need more and more tools, right? And the network control systems, they're becoming increasingly more complex. They include more and more components, more and more systems, and also they differ quite significantly between different TSOs, different ISOs, utilities, locations, and so on. Now, for example, as one of the largest, basically biggest vendors providing network control solutions in the world, we do support hundreds of customers. And no matter how our portfolio being powerful, huge, large, we are still not able basically to fulfill all specific needs of all our customers. Same as everyone else, we are also resource constrained, right? We cannot scale up our organization to tens of thousands of people to develop all of that. So what's the solution? Of course, we need to offer open system, as open as possible, to make it possible for our customers, together with their other partner software vendors, to implement also some parts of their own solution, right? So that's something that we absolutely agree here. Now, I think what is the key here, there are of course also challenges with that approach. It's also, I would say mainly it's about accountability, because if something goes wrong, now if you got 10 different vendors and tools in a chain, good luck resolving the problem, right? So that's why I think that, for example, certain key components, they need to come, let's say, from one source, one vendor. Here we are talking, let's say, about pure SCADA, data processing, alarm, event management, and that kind of stuff. And then, for example, the next building block could be EMS, one block could be VAMs, and that kind of stuff. So that's something that's definitely happening. We need to make sure that our system is easy to integrate with, get data in and out of it, and make it possible, not to make life hard for our customers to do that, but actually to help them with that, right? We want, basically, our idea is to own the base of a system and to offer as many out-of-box solutions as possible. Of course, we are not running away from customization and stuff, but still, maybe it's better that if you can take care of it, you can do it. But we want to basically to own the base. And now, this, of course, here we are talking also about the modularity. You touched the topic of open source solutions, or even basically solutions from other companies. I think in my mind, the biggest challenge with open source is actually security risk, because code is open, everyone can see it, and all vulnerabilities are easily detected and then exploited. That can be quite problematic, especially in some markets. On the other hand, same thing, network control systems are growing increasingly complex. We don't want now to have to reinvent the wheel for everything. We don't want anymore to develop our own database. We did that in the past. Now we don't. There are basically industry standard solutions available. We don't want basically orchestration tools, like, for example, Kubernetes. We don't want data bus to develop monitoring tools and that kind of stuff. We want to pick the best solutions that are there on the market, put them, package them, put basically what we do best is domain-specific things that we develop. And, sorry, I didn't do it. And we deliver it, right? Then, of course, we have to think about upgradability of those solutions, because especially some of these tools, they have a quite short life cycle, which means that we have to make system also upgradable quickly, keeping the cost under control. It's not secret, basically the price of network control systems is going up because requirements are going through the roof, right? Some years ago, all you needed was reliable SCADA, state estimation, power flow. Today, you need a lot more things, DSAs, TSAs, optimal power flow, VAMs, and so on and so on. But I think maybe I'm a bit biased. It's money well spent, right? Because if you compare it, the price of an overall system of equipment, of hardware equipment, it's really nothing, and it pays, you know, order of magnitude more. So yeah, it's quite interesting. I think it's definitely the direction in which industry is going. We support that, but with the certain these comments that I said, we have to be very careful what we're doing there.
Thank you for this reality check. But we move now to Janko, and maybe if someone has any feedback, he can provide it to the end. Janko.
So, if solutions are ready, we are ready to test them. And I think this is the only right way to go, that we make tests, pilot projects, that we see how the integration works, how the integration of existing support systems can be done using this new technology. I believe that there will be hurdles, I'm sure, but I'm also confident that at least at ELES we are willing to overcome them, because this is the only way we should go. The main objective of ELES is to lower the labor costs for maintenance of different support systems, because maintaining different systems to keep with the changes in the network is a huge task, and this task is very hard to be performed well. I would say what is ahead of us is more than a task. It's a mission. It's a mission we should devote the best engineers to it, and hopefully in next year get excellent results.
Thank you. Anyone to react on any position? Not really? Okay, then maybe we have a few minutes for some questions from the audience. Is there anyone brave enough to start?
Is it really just about bravery?
Okay, maybe.
I guess we have a lot of brave people here. Yeah,
okay.
Just I can bring the microphone.
No?
Oh,
okay.
yeah.
We have a hand. That's great.
Hi, I'm Marco Compare from ELES. A question. A few years ago, it was very, let's say, modern to talk about self-healing networks. What is this about? Do we go into this area that the networks will not need so much centralized and that they will be able to, let's say, to find a way how to eliminate the blackouts and so on?
Who would be able to respond? Ralf, please.
Maybe I can respond with some ideas and then others can join. Self-healing network means solving the problem. And solving the problem needs right data. And if we talk about SCADA data as a standard with 1 second resolution and the accuracy we know, it's too late for the problems we face. So we need higher accuracy, more located information where the problem occurs. And we're talking about VAMs and PMOs, which provides more data, but we are far from using these data for decision taking. So the need is there. I think the solutions are not ready to be used today. So we know where the data come from, we know how to combine them, we know that there are lots of algorithms for inertia analysis, oscillation detection, harmonic detection, all the single things. But really self-healing means that we can manage the circus of phenomena. And this is missing.
But special protection schemes, are they
also one
ready?
part in my view.
Yeah, okay. Good point. So any more questions? Yeah, we have another one, please.
Okay, right here you go. Marina, here, so you were probably closer to the control room than anybody else, but there has been a lot of mentioning throughout the summit of, we have a lot of data, we cannot use it. You just mentioned there's a lot of algorithms, we are not using it, we are not ready to use them. I'll be really interested, what is preventing you from using this algorithm? Lack of resources, lack of time, lack of talent, a combination of all of it together? Yes, thank you.
Yeah, thank you for the question. Yes, regarding the data and the algorithms that are used in the control system, I can say that everyone wants to use the data. No one wants to clean the data. Cleaning of the data is one of the, you have to have the data that can be used in the algorithm, and if this precondition is not met, then all the algorithms will not be successful on this. Applications will not be accessible. Also, we have a really large amount of data that comes into the control room, different types of data from different measurement systems with different time scaling, different quality, and so on. And integrated that, and you need to be aware of what data you use for what process, and if this data, this measurement or any other type of data was really meant to be used to be used in this different algorithm or application or process and so on. Definitely. Why we don't use, recently I read a nice quote that said the data is the new oil, because the one who owns the data and has the data is rich today. But we really have to know how to use it, and this is something that I think that in the TSOs we lack some data analysts that will know how to manage it and how to clean the data and how to use it in a proper manner. Regarding the algorithms that we use we use with this data, definitely there are this confidence gap on the operators. When you want to bring some new algorithm, a new application, you have to bridge this gap of confidence, that they are confident with using this new application or new process. And this is why I think, this is my opinion, is going this quite slow.
Thank you. Thank you for the questions, and thank you for panelists for extremely good discussion. I would just like to finish by saying that I know that some Horizon calls are coming in 27 on this topic, and I know that a lot of people in the room are from this field, which will prepare consortiums. Grab the people, grab Renata, grab everyone. These are the perfect candidates for your consortium. But of course, you will have to be very convincing to get them in the room. Okay, so I finish here, and thank you.
It's a great comment to conclude the panel. Thank you, Uroš. Thank you to all the panelists. And as we come to a close of this year's summit, I would just like to thank once again, really sincerely, to all of our speakers, to all of our moderators. They did an amazing job, and I would like to ask you to please accept our apologies for some special sound effects that we had during the summit. We were actually just testing your patience, and it looks like you're really patient. Thank you. So now I kindly invite Frédéric Simon from Carbon Pulse, who was the moderator of the Executive Roundtable in the morning, and Eduardo Vega Fanul, Project Advisor for CEF-co-funded electricity and smart grid projects at CINEA, European Commission, to share with us the concluding reflections of today's summit. Please.
Thank you. Yes, these are conclusions that we put together today, so forgive us if it's not entirely clean and maybe a little bit messy, but yeah, so please bear with us. Today we convened a very diverse group of experts from the smart grid community. We had operators, regulators, energy organizations, institutions, technology vendors, the whole range. Discussions were, wide-ranging because of this and focused on the challenges and future directions of smart grid developments. So let me mention the few challenges that were identified, and these were across the different panels because a lot of the topics cropped up in all the panels. First is the aging electrical infrastructure. A second one is the complexities that comes from shifting towards decentralized system, or from centralized to decentralized systems, with the integration of renewable energy sources and new participants coming into the system, so EVs and all of this. A third challenge is related to the increasing vulnerabilities due to extreme weather events caused by climate change, as well as cyber and physical threats. And then a fourth challenge relates to the potential bottlenecks from supply chain disruptions and permitting delays. I could add investments as well to try and address all of these. Eduardo, I'll leave you to do the rest of the presentation.
Thank you, Frederick. So it has been a last-minute cooperation, so please forgive us if something is forgotten. But okay, we did not only see challenges, we also saw hope. There were solutions. And what was very interesting to see is that it was articulated through several speakers, a vision. So we all are understanding that we are embarked on an energy transition towards a decarbonized and fully independent and efficient energy system. And this transition aims to provide fair, competitive energy prices across Europe for the end users, for the European citizens. However, we do not understand nowadays energy transition happening without having a smart, integrated and resilient European energy system, where electrification will play a key role. So this would be the vision, and to accomplish this vision, modernizing our infrastructure is crucial, both digital and physical, as we understood here from many speakers that were making this very clear. And for that, strong investments are needed in the grid, and they need to be backed up by a good planning and streamlined permitting processes. Anticipatory investments supported by aligned financial frameworks are also crucial to accommodate fast growing demand and rapid development of renewable energy sources. Regulatory frameworks must evolve to support the integration of flexibility and innovation in the grid infrastructure also. And there is a clear pressing need for regulatory frameworks that incentivize investment in modern, flexible systems rather than the traditional models that we all know. We can also say that coordinated regulatory and financial efforts are necessary. In this way, we can ensure that investments are finally materialized. And digitalization and smart technologies should be the means, but not the end. That was also clear during all discussions. And they should be seen as enablers that offer substantial opportunities for enhancing operational efficiency. Also decision-making and setting strategic priorities through improved data collection and analysis. Finally, I would like to mention the importance of cooperation. In an interconnected European energy system, cooperation among the various stakeholders is paramount. Programs such as the one I work for, CEF and Horizon, where many examples who have taken from today, serves as catalyst, reducing fragmentation and facilitating knowledge transfer and replicability. So a specific example that we were discussing extensively today is about artificial intelligence, which it seems that is here to stay. And cooperation is essential for the rapid development of models that will enable Europe to achieve sovereignty and independence. However, all these technological challenges require that humans remain involved in the full process, and they have close monitoring associated to the risks. So they are always in the loop. I hope that I cover most of the things that were discussed, because it was very challenging, believe me. I was coming just here to sit in the chair for the first time and it didn't happen. But to conclude, I would like to extend my gratitude to all attendees, and special thanks for ELES. That the role in organizing the event was incredible, especially because it was very last minute. And yeah, to finalize completely, I promise, I would like to invite you to continue these discussions in the Energy PCI Days in December. And hopefully next year, thanks to colleagues from ZSD and VSD in Slovakia, with the 5th Smart Grid PCI Summit. So thank you very much for coming, and hope to see you soon.
Thank you. So we have just one final surprise for you. It is now time for the official handover of the organization of the next Smart Grid PC Summit. So I'd like to invite to the stage Simon Todt, Project Coordinator of Green Switch, and Mr. Tomáš Sipos, Project Coordinator of DUNOP in Grid. Okay, yeah, you take the central position on the stage, please. The organization of the next summit is being handed over to the project promoter DUNOP in Grid Zapadoslovenska Distribučna. On its behalf, Mr. Tomáš Sipos will officially take over. And we're pleased to announce that the Smart Grid PCI Summit 2026 will take place in Slovakia, in Košice. In Košice. So it is Košice. It is official. Thank you, gentlemen.